Alright guys, ready? Let's start. Matt.
Hi guys, my name is Mateusz. I'm one of the platform engineers at BJSS as well, at Jake for 3 years. My topics are around ExpressRoute. It's quite tech-heavy topics. So what I wanted to check is how many of you are platform engineers, cloud engineers, or okay, quite a bit actually. Nice. So hopefully should be easy to understand. If not, I'll try to keep it as simple as possible. Which brings me to the agenda. And what I want you to take out from this talk is what is ExpressRoute, what are benefits and use cases. We're gonna explore connectivity models of the circuit and have an architectural deep dive and a demo of an actual circuit. I deployed some of this stuff already because otherwise we'd be here for an hour because a lot of networking, if you work in platform, you know that networking stuff takes like half an hour or an hour to deploy sometimes. So we'll be here all day. So yeah, ExpressRoute. So a simple explanation of what an ExpressRoute is, it's a layer 3 connectivity from your data center to Azure cloud. So yeah, it doesn't go over public internet. So if you ever set up VPN connectivity from on-premises to cloud or maybe between clouds, this is an option where it doesn't go over the internet. It's quite expensive, but if latency and output is what you're aiming for, with good SLAs, that's the pretty much choice that you got. And like I said, you got flexible connection models. So I'll try to explain those soon. So if we get to the architecture deep dive, that's the sort of model that's shown by Microsoft of what the ExpressRoute circuit looks like. And I want you to focus on couple of these elements. So we got 2 elements here. One of them is Microsoft peering for M365 services. So what is this? So M365 services, as we all know, Outlook, for example, they're the services that Microsoft has that are public. And the advice from Microsoft is to, unless you have very strong compliance or regulatory pressures, is to use public endpoints of this and not go through ExpressRoute. And then you have the other link, which is the Azure private peering. And that's essentially if you have a virtual network in your cloud and you want to talk from your network in your data center to this virtual network, or the resources that are in that network, for example, VMs, or let's say you want to connect to SQL or whatever you deployed with private networking for security, you do it over this. And in a ExpressRoute circuit, we have the customers network, so that's our network. Let's say we're an enterprise. We have our network stack and routers, so that's the area. Let's say if we have the data center here, that's the customer's network. Then we have the partner edge. So the partner edge is a company. They're usually big network service providers. Think BT, Equinix, I think is a really large American company, Megaport. And they essentially help these enterprises to connect with Microsoft. So all this connectivity is over fiber and these massive circuits. And you have primary and secondary connection. So these are for redundancy. And as you can see, you're connecting to the Microsoft Edge. And what Microsoft Edge is a physical location, a data center, where all of these different service providers, they meet. So they have their network gear in those locations. So Microsoft would have their routers and switches in there, and for example, Equinix would have those devices as well. So yeah, like I talked about, on-premise DC network, customer edge. That's also referred as A end in this sort of peering. So A end will be our customer, and B end would be the Microsoft end. Then partner edge is the the provider side, and like I mentioned, MML, they're the meeting locations, and the connections essentially are the connections between our router and the Microsoft router, over which we establish the connectivity. So these are the sort of models that Microsoft supports for setting up ExpressRoutes. And you can see there's more on this side than there is on this side. So the service provider model is the model where we are using services of these providers, like Equinix, to help us establish this connectivity to Azure. So if I can explain to you the difference between, for example, Cloud Exchange colocation and point-to-point Ethernet connection, is that if I'm an enterprise large enough to have my own routers in this meeting location, I'll use the Cloud Exchange colocation because I'm already present in the meeting location. So I can directly connect to the Microsoft router at the meeting location. And point-to-point is where, for example, you're asking BT as a provider to run the connection from your data center to this meeting location. So then that connectivity is managed by BT, and you're just paying them, and they're managing this connection for you. And then you essentially terminate at this meeting location. Now, that's with a provider. And then the most expensive one and the best one is the ExpressRoute Direct. That's where you're pretty much managing the entire thing yourself. So in this model, we are connecting through the providers. So if you think about a router and a physical switch, the providers plugged into the switch of Microsoft, and multiple customers are sharing that physical link. So the speeds are not as fast. Obviously, it's still private, the traffic segregated, but you're still sharing this physical port. In the direct model, you're essentially buying the port. So you own the entire port, only your traffic is going through this port, and that gives you much higher throughput. So if you have like very high enterprise grade workloads that need really fast speeds over private connectivity, then that's what you'd be using. And you can think about, for example, financial institutions, maybe defense contractors. Think about these sort of clients that would be using something like this. So yeah, like I said, no provider involved in the direct. Bandwidth's 10 gig to 100 gig. And yeah, higher cost of implementation, but you also have the global connectivity, so you can connect to other, because not only you can connect clouds, you can connect your other data centers. So let's say if I had a data center in Tokyo, and I had a data center in UK, I could connect these also through ExpressRoute, through the backbone. And the reason why this is possible is because Microsoft owns so much cables, like all the cabling. They have a big chunk of that, so they can provide this sort of services. So now we're getting into the very beefy stuff of how this stuff is implemented. So I'm gonna try my very best to explain these concepts. So when you're setting up this ExpressRoute connectivity and these peerings, what you have to set up on your router on the customer edge is a VLAN, which is sort of like a private network. You logically separate the traffic for each one of these peerings that I mentioned, the private and M365. And what you tag it with is a VLAN ID. So for example, you tag the private one with 100. Imagine you're, putting this traffic in this envelope, putting an address, and off you go. Now, Q is sort of scaled up version of VLANs, is also known as VLAN stacking, and that's used by these massive network service providers to segregate all their customers' traffic. So for example, our traffic's coming in with a VLAN 100, and then the provider will tag this envelope with their own tag, just so they know where to sort it, down, and where it needs to go. And that's used in the service provider model. So we're not really worried about that because it's like hidden away, but it's good to know that this exists. And then BGP, that's a protocol in networking. Essentially, it allows routers to dynamically exchange routes to different networks. And I don't know if you guys remember when Facebook went down and nobody could access it. And that was because one of the network engineers misconfigured BGP on one of the routers, and it started propagating the routes. So Facebook just went down all over the world. And that was because all the routes were not propagating down to all these other routers across the mesh or the fabric. So yeah, that's that. And that's how a BGP configuration will look like on a Cisco router. So we defined this is what is known as ASN, which is Autonomous System Number. So these networks, they have these ASN numbers assigned to each other. So, and that's how these big networks are identified. So what this says is just, I have this neighbor, that's its autonomous system number, and that's the private peering to Azure. So this is the router with this ASN on the Microsoft side. And this is us, the local AS number. And you activate, you give it a password, so the BGP is encrypted, and then you redistribute the routes. And what that does is it sends all the routes that are known by this router over to Azure. So we're sharing the routes from our data center to Azure, and Azure is sharing the routes back to us. So for example, if you have a virtual network in Azure, we'll let, for example, it will let my PC know that if I want to connect to 10.0.0.0, I need to, that's a network in Azure and not in my network. And I can, for example, ping a VM and go over ExpressRoute to the device. So yeah, like I said, I will get to the demo. Like I said, pre-deployed a lot of this. So I'll just walk through how the setup looks like on the Azure side and the provider. So when I mentioned the service provider I'm using is called Megaport, and the reason I'm using them is because I don't think there's any other provider that allows you to spin this up yourself. Otherwise, this stuff just costs so much money. It's crazy. I mean, you'll see even with this that it costs quite a bit. So you can see that I've got what MCR spun up. What that is Megaport's virtual router. So because obviously I'm not rich enough to have my own data center, that's one way I can sort of spin this up. So if you think about this, this is like we're connecting from the provider to Azure, and we can then see the routes. So if you go into the services, you'll see I got the router, and then I have the connection, also known as virtual cross connect. and you can see it's through Azure. It's only 50 megabits per second, because otherwise it just costs a lot of money. And I'll show you how the connection gets set up. So if we go into the details, yep, you'll see that it's live. That's the ASN number. BGP is enabled, so we have the route exchange. Where can I get that? What I'm looking for, there's actually I can show it on the Azure side. So on the Azure side, we have the circuit. So this is the logical representation of the circuit. You can see that it's provided by Megaport. It's provisioned. The peering location is in a Equinix data center in London. That's the bandwidth. And when you're setting up this connection, when you create the circuit, you're given the service key. And you can think of it as sort of like an API key. And that's what we need to provide to Megaport to establish this connectivity. So if we go back, I think it might be on the actual cross connect. Oh, right. You can see that we got the VLAN set up that we want, because what's happening is when we send the data from the customer edge, we slap this VLAN on 100. Then the provider slaps their own, so they segregate our traffic. But then Azure, once it leaves the provider's network, it strips that off, and that's what Azure expects to come on their end. So it's like part of the same network. Also, when you're setting this up, so to enable this peering, you need to use two IDs from the same network. So it's the /30, and that's essentially to set up this BGP connectivity. So if you think about subnet 1, one of those IPs will be assigned on the customer end, on the router, and one will be on the Azure side. And that's to establish one of those connections. The second one is to establish the second one, and you can see it's on a different network. And also, it'd be one IP per router. So, and that's for high, so it's highly available. So normally, the way this is set up is you have two routers in your data center, one having one of those peerings. So if one of them goes down, you still have connectivity. And this setup is required for Microsoft to honor their SLAs, which I think with this setup is 99.95% uptime. So once we got the circuit, we provide the service key. Everything's running. And then on Azure side, what we also need, so you can see that I got two networks. I assume a lot of people are familiar with hub-spoke topology. That's the sort of networking standard topology in cloud. So normally the way this is set up is you have your hub, so your core network, spoke, that's peered, and then within the hub you would have a firewall and your circuit, and you also would have a gateway for the ExpressRoute. So instead of setting up a VPN gateway, you set up a ExpressRoute gateway. And this is what actually does the route exchange. And if you look at the connections, you also need to do a connection from the circuit to the gateway. So you can actually egress out from Azure to your data center. Now if we look at the IP addressing of our hub, we can see on the network that it's on 10.0.0/16. And also for the spoke, we can see it's 10.1.00.16. If we go to the portal, I think, yeah, here, I'm just gonna look at this. If we look at the BGP table, it's gonna load. Yeah, we can see that the routes have been propagated to this router of both of our networks, and that the next call is through this connection. So these routes would then get propagated down to our routers in the data center. And they would know that if anyone wants to connect to these virtual networks, they need to go to the ExpressRoute circuit. So this pretty much proves our connectivity from Azure to the MCR. Now, a very good use case for example, this virtual router would be, so we have Azure. Let's say you wanted to bridge AWS with Azure. Yeah, you would set up an MCR. You would do this cross connect from the MCR to Azure, and on the other end to AWS, and you would have cross connectivity from your AWS cloud to Azure. And you could have workloads from both platforms speaking to each other. So you don't have to settle for one cloud. You can do that for both. So yeah, I think that's everything from me. I'll answer any questions if anyone has any. Actually, before that, I wanted to show you when I was talking about pricing. So for the MCR with just 1 gigabit per second port is £600 per month. Thankfully, it's a pay as you go, so I won't be paying a lot of money at the end of this now.
You said Megaport, are they still the only ones that can do this sort of thing for setting up an automated?
That's a good point. Megaport is the only, I think, provider that allows you to spin this stuff up. Normally, you have to go through procurement with big telcos to get all of this. And yeah, I've done it on one of the clients I've done. I worked at for BJSS. Actually, that's how I got to this talk. It was a financial industry, and yeah, it's one of those things that you normally set up once and you forget. And normally in places that are very greenfield or are moving to cloud, you might set this up, but I only seen it twice in all the time I've worked as a DevOps/platform engineer. So
how much is the minimum that you could set it up with Megaport?
I think that's the minimum.
That's the minimum.
That's the minimum.
So, interesting.
So I think it's £600 for the MCR, and then
is there an Azure charge on top of that as well?
Yeah, and then you also pay for the circuit, ingress, egress. So yeah, it gets very expensive. But normally places that are deploying this, they've got the money, so don't worry about it. Anyone else? Yep.
Does this also set up like the firewall connections, so SD-WAN and VoIP through Equinix, or is it just the network edges?
No. So the way normally you have this set up is you would, let's say the traffic comes in through the gateway, and you would force the traffic through Azure Firewall on ingress, and any egress from Azure you would also force through the firewall on the Azure side. But you could, you also can force it through the, when it hits your customer edge, you also run it through firewalls, so anything that comes out gets checked. But yeah, this is, if you think about it, purely like layer 2 connectivity across, and then you're just managing the layer 3. So you're responsible for the VLAN, the BGP configuration on your end, and then it's more automated on the Azure side. Well, yeah. it'd be different if you went, with UR direct, then you're more, responsible in that field. Yeah. Yeah.
So these two connections are just for HA, no load balancing.
Yeah. So, what do you mean by load balancing?
The traffic for customer balancing in a two-way for two different connection, two different BGP number.
Yeah, so this would be, the way this is currently set up is just from Azure to the central router, the virtual router. What you would have to do if you wanted to connect, for example, AWS, is spin up another virtual cross connect on the other side and connect to AWS, and then you would have, the end-to-end. And MCR is, literally, I think this is the biggest use case, is to connect two clouds together. Because normally, you already have a data center, you have your routers, so you wouldn't need this. You would just connect your router through this provider to Microsoft. So your on-premise to Azure, for example. Yep.
I have a question. So we have to use this one to connect two clouds together, AWS and Azure.
Not necessarily. So you could also spin up a VPN between the two.
No, if you want to use ExpressRoute.
Oh yeah. If you wanted yourself, not as a business.
But as a business, let's say, there will be more direct ways to connect them?
No, this is the.
So middleware.
Yeah, this is the most direct way. So with VPN, you would go over the public internet. If you want, I don't know of any other way you would have private connectivity to Azure.
But Azure and AWS doesn't offer any services similar to make a direct connection there.
Well, this is the factor offering for this.
Okay.
I forgot what the one in AWS called. I think is AWS Direct. Yeah, it's the. And actually, on the current client I'm working on, this was sort of what we wanted to propose to them, because they have a big AWS presence, and I'm currently working on their Azure platform. And what we have right now is a VPN connection between the two, but this would be the preferred way.
Okay, thank you.
Yeah, no problem. Anyone else?